Okay, so now we are going to take a look at the total product, the marginal product, and then the average product, and what they mean, the formula that we use for finding these products. So we are going to start with the total product. Okay, so when we talk of the total product, it is the total quantity of output produced by a firm. Okay, so the total quantity of output produced by a firm. So if, for instance, you have, I mean, a farmer who owns this farm over here, so owns the land, and then I have this over here as the farmer. And before I even continue with this, I mean, example over here, I want you to note that this analysis that I am going to carry is in a short run. Okay, so now I am in a short run, and in a short run period, I am sure you remember what this period is, right? So this is the period where at least one of the the inputs or one of the factors that we use in production are fixed. So in this case, I am going to assume that this land over here is my capital. Okay, so I assume that the land is fixed and my labor, so this is the labor over here, so this labor over here is the variable. Okay, so this can change, but then this is the land, this is fixed. Okay, this is fixed. Now when I have this land over here and I have this labor over here, now the number of maize, all right, so this is a maize farm, so the number of maize that this farmer over here is able to produce in the short run, the quantity, right, the total quantity of maize that the farmer is able to produce in the short run is what we refer to as the the total product. Okay, so see the total product as the number of output, the quantity of output that the firm or the farmer, in this case my farmer, is able to produce. So if in the short run the farmer was able to produce just this 3 maize over here, then the total product for the farmer, just one farmer, okay, just one, this is one, just one person, then the total product for this farmer over here is going to be 1, 2, and 3. So the farmer was able to produce 3 maize in the short run. Okay, so the total number of output, the number of products that you are able to come out with in a short run, that is the total product. Now let us take a look at the marginal product. So when we talk of the marginal product, it is the extra or the additional output resulting from one additional unit of variable input. So in this case, my variable input is the labor. So let me put into brackets labor. Okay, because I am in the short run, and in my short run analysis, I am assuming that my labor is the variable input and the land is the fixed input. Okay, so again, let me take the definition again. So the marginal product is the extra or the additional output resulting from one additional unit of labor. Okay, so with the total product example, we had one farmer producing 3 maize. Okay, so this one farmer over here was able to produce 3 maize. Now, which is the same thing as this. Okay, so this is the farmer, just one farmer. He was able to produce 3 maize. Now, if I add an additional farmer to this farmer over here, so if I have 2 farmers, now I am able to produce 1, 2, 3, 4, 5, 6, 7, 8. Now my total product, right? Remember what I said about the total product. So when my labor is 2, so when I have two farmers, right? So I have my labor is 2. So when I have 2 labors over here, then the total product is going to be 8. Now, when it was 1, so this is when I have my 2 labor. When I had just one farmer, when I had just one farmer, the, the total product, just that one farmer was able to produce 3 maize. Now, just by employing the second farmer, which is this farmer over here, now I have been able to increase my product from 3 to 5. So it means that just by employing the second farmer, I have gotten 5 additional maize. Okay, so now I have gotten 5 additional maize. So when it was just 1, I had 3 maize. Now I have 2 farmers and I have 8 maize over here. So just by employing the second farmer, I have gotten 5 additional maize. So this 5 over here is what we refer to as the marginal product. So that is the marginal product. So the marginal product is the extra. So take note of this. So the extra or the additional output. Okay, so the extra output. So in this case, the extra output is 5. Right, so the extra output resulting from one additional unit of variable input or labor. So just by adding another labor, by how much has the maize increased? Okay, so just by adding another labor, my maize has now increased from 3 to 8. So it means that I have now gotten 5 additional maize. So that is what the marginal product is, right? So the extra or the additional input from employing an extra or one more variable input. That is the marginal product. Now, the average product. When we talk of the average product, with the example that we have seen before, I mean, when I had just one farmer, I was able to produce 3 maize. But then when I had 2 farmers, I was able to produce 8 maize. So with 2 farmers, when I have, so let me have my farmer over here. So this is my farmer, okay? So when I have the farmer, now we are soon going to look at the table for this. So this is just, I mean, to explain something small. So when I have the farmer over here, now let me call this over here my output. Okay, so when I had just one farmer, I was producing 3 maize. Now with 2 farmers, I am now producing 8 maize. This 8 maize over here is the total product for 2 farmers. Okay, this is the total product for 2 farmers. Now, on an average, when we say an average, it means that if I am to distribute this 8 maize over here to the 2 farmers evenly. So evenly means that they should get the same number of maize. Okay, so if I am to distribute this 8 maize over here evenly to the farmers, then how much is each going to get? That is what we mean by the average. So with our case over here, if we have 8 total, the total product is 8, then on an average, it means that every farmer was able to produce 4 maize. Right? So this is what you have over here. So it means that on the average, every farmer produced 4 maize. So remember that we have 8 maize, right? So you take note. The total product over here, if the labor is 2, if the labor is 2, the total product is 8. Now we are distributing this 8 maize over here to the farmers, and they should get the same number of maize. So if I distribute it to the two farmers over there, then it means that each of them is going to get 4. Now for the case of the one, if there is only one person over here, then of course the average is just going to be 3, which is the 3 maize over here. Okay, so there are 3 maize over here. But then if we have 8 maize, then 2 farmers, we divide, so we do 8, the number of maize divided by the number of farmers, and then we are going to get 4. And that is how to find the average product, right? So the definition of the average product is, so it is the total quantity of output per unit variable. So on the average, how much was each labor able to produce? So it tells us how much output each unit of labor produced on the average. Okay, so just like the way we find the average, the normal average in mathematics, it is the same way and it is the same meaning over here. Okay, so if we are to distribute it evenly to all the farmers over there, then each of them is going to get how much? That is what we mean by the average. Now we are going to look at the table over here. So in this table over here, on this side, this contains the units of variable input, which we are taking it as labor. So the first over here, if we don't have any labor, so if there are no farmers, if you have just one farmer, if you have 2 farmers, if you have 3 farmers, 4, 5, 6, 7, 8, 9, 10, 11. Okay, so this is the number of farmers. And then we have the total product. Okay, so the total product over here means that if we had 0 farmers, of course, if there are no farmers over there, then the total output is going to be 0. If we have just one farmer, okay, if we employ just one farmer or one labor, let me stop using the farmer. Okay. Let me use the labor. I'm sure you understand what I'm trying to get to. So if I have just one labor, then the total product is going to be 2. So this means that, okay, let me use the farmer again. So if I have just one farmer, okay, if I have just one farmer, then I'm able to produce about 2 maize. If I have 2 farmers, then I can produce maybe 5 maize. If I have 3 farmers, then I can produce 9 maize. If I have 4 farmers, I can produce 14 maize. If I have 5 farmers, I can produce 18 maize. If I have 6 farmers, I can produce 21 maize. If I have 7 farmers, I can produce 23 maize. If I have 8 farmers, I can produce 24 maize. If I have 9 farmers, I can produce 24 maize. If I have 10 farmers, I can produce 23 maize. And if I have 11 farmers, I can produce 21 maize. Okay, so that is what the total product over here tells us. The number of output, the quantity of output that we get from the labor, the number of labors that we have employed over here. And now the marginal product, the formula for the marginal product is given as this. So the change in the total product over the change in the labor. So change in TP over change in the labor. So in this case, there is going to be change in this is the labor, and this is the TP, right, the total product. So to find the labor, the marginal product. So for the first one over here, if the labor over here is 0, then of course this over here is going to be dash. Okay. The reason is we are going to get the denominator over here to be 0, and if that happens, then we are going to get an error. Okay, that is a mass error. So if the labor is 0, you don't even need to bother yourself to calculate anything. Of course, this range is going to be dash if the labor is 0, because there is no one employed. Now, if we have the labor to be 1, and you want to calculate the marginal output when the labor is 1, now you come to use the formula over here, the change in the TP. So let me call this over here maybe TP1. So this is TP1, and call this over here maybe TP2. Okay, then let me call this over here maybe my labor 1, and this is labor 2. Okay, so now if I want to calculate the marginal product, then it is going to be the TP1 minus the TP2 all over the labor 1 minus the labor 2. So the change in the TP over the change in the labor. So it is going to be, so this is the TP1, which is 2, then minus 0. So the 0 over here is for this. So the TP2 all over the L1. The L1 is 1. So the labor is 1 minus the L2. The L2 is 0. So when you do this, you're going to get 2 over 1, which is equal to 2. Okay? So that is the marginal product when the labor is 1. Now when the labor moves from 1 to 2, okay, so the labor has now moved from 1 to 2. So now this is now going to be maybe my L1. Let me call this maybe my L2. Let me call this maybe my TP1. Let me not use the 1 and 2. Let me use the maybe old and new. Okay, let me clear this. So let me say that this is the old labor. Alright, so I move for the old from the old labor. So this is the new labor. Okay, this is the new labor. And now this is the old TP. So right, when the labor was 1, that is the old labor. So the old one. And this is the new TP. This is the new one. Okay. So now if I want to calculate the marginal product for when the labor is 2, it is going to be the TP, the new TP, right? The new output. That is going to be 5. So it is going to be 5, then minus the old total product, which is 2. Right? So the new minus the old. Right? Then all over now the new labor. So we have moved from 1 to 2. So the new labor is 2. So the new labor is 2, and the old labor is 1. So minus 1, which is this. Right? This is the old labor. So now when I do this, I'm going to get 3 over 1. So I get 3 over 1, which is equal to 3. That is how come you see 3 over here. So now if the labor is 3, right? So if we are moving from, so now we are moving from 2 to 3. We are moving from 2 to 3. Now this is going to be the old labor, right? So we are moving from the old one now to the new one. So this is the new labor. And this is the old total product. Okay, this is the old one. And this is the new total product. This is the new one. Okay, so now to find for the marginal product, it is going to be the change in the TP. Okay, the change in the TP is going to be the new one minus the old one all over the new labor minus the old labor. So it is going to be 9 minus 5, which is this 9. So this 9 over here minus this 5. Then all over, so the new labor is 3, the old labor is 2. So 3 minus 2, and that is going to give us, so 4 over 1. So 4 over 1 is just going to give us 4, right? So that is how come we have this 4 over here. So you do the same thing to complete this table. So for instance, if you want to get the marginal product when the labor is 7, all right? So when the labor is 7, if you want to get the marginal product, then it means that we are moving from this to that. Okay, we are moving from the 6 to the 7. So now this is going to be the old labor. This is going to be the new labor. Then this is going to be the old TP. So the TP is old, right? So this is the old TP. Then this is going to be the new TP. Okay, so we are looking for when the labor is 7. Okay, so there's going to be 23. So in this case, we get 23. That is for the new TP minus the 21. So minus the 21 all over. So 7 minus 6. So 7 minus 6. And that is equal to 2. That is how come we have this 2 over here. Okay, so you can do the same thing to complete the table. And now the average product. When we talk of the average product, it is so the total product divided by the number of labor. So you take note of these two formulas. For the marginal product, it is the change in the total product over the change in labor. For the average product, it is the total product over the number of labor. Okay, so with this, if you want to find the average product when the labor is 1, it is going to be the total product divided by the unit of labor. So 2 divided by 1. So 2 divided by 1, you get 2. If you want to get the average product when the labor is 2, so you take the total product, which is 5, divided by 2. So 5 divided by 2, so 5 divided by 2, right, is going to give us 2.5, which is this. Okay, so 5 divided by 2 is 2.5. Now, if you want to get the labor, the average product when the labor is 3, now the corresponding TP is 9. Okay, so there's going to be this TP over here, that is the 9 divided by the 3, and then you're going to get 3. Now, if you want to get the average product when the labor is 4, now the corresponding TP, the corresponding total product is 14. So it is going to be 14 divided by 4. That is going to give us 3.5. So you can do the same thing over here to fill out the table, and that is the formula over there. Okay. So now, if you want to plot this over here on the graph, now on the vertical axis, we are going to have output. On the horizontal axis, we are going to have the variable input, which in our case, we are assuming that the variable input is the labor. So I told you that over here, we are in the short run. So the variable input over here is labor, and then we have the output on the vertical axis. Okay, so the variable input is on the horizontal axis, the output is on the vertical axis. So you plot the point. So we have the labor 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. As you can see over here, we get to 11. Okay, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. That is what we have over here. That is the labor. Right, the labor. And from this over here, the total product. Okay, I mean, I used the maximum over here as 25. Okay, because we don't even get up to 25. Then you can plot the point. So when the labor is 1, you can check for the corresponding, I mean, total product. So when labor is 1, the total product is 2. So there is 2 over here. Okay, this is 2. And now when the labor is 2, I have 5. So when the labor is 2, so when the labor is 2, then I map it to, so this is going to give me the output to be 5. Okay, and when the labor is 3, the output is 9. So when the labor is 3, I am somewhere over here. Okay, when the labor is 4, so when the labor is 4, I get the output to be 14. So the output is somewhere over here. So this is going to be 14. There is 14 over here. Okay, when the labor is 5, I have output to be 18. So when labor is 5, my output is 18. So 18. So when you do that, you're going to get. So you can do this over here with your graph. Okay, with your graph, you have the lines over there to guide you. Okay, so when you're done with all these, you just draw a curve to pass through these points. Okay, So you just draw a curve to pass through this point over here, and then you have your curve for the total product. And you can do the same thing for the marginal product as well. Okay, so we have on the horizontal axis, I have the labor. On the vertical axis, I have the output. Then I put the corresponding values in there. So when my labor is 1, the marginal product is 2. So when labor is 1, the marginal product is 2, as you can see over here. So when labor is 1, the marginal product is 2. Okay, and when labor is 2, the marginal product is 3. So when labor is 2, the marginal product is 3. So you can do the same thing. You plot the points, then you draw your line beautifully to pass through them to get your marginal product. Okay, then you do the same thing as well for the average product. So you plot your points. So when the labor is 1, the average product is 2, and when the labor is 2, the average product is 2.5, and so on. So you plot the points, you draw your line to pass through, the curve to pass through, and then the point over there, and then you have your average product. Okay.